There are transmissions that confirm what we expect. And then there are transmissions that challenge everything we think we understand. After more than 4 decades drifting through deep space, Voyager 2 is still sending signals back to Earth. Faint. Delayed. But incredibly valuable. And recently, one of those signals sparked a wave of speculation, not because it proved something extraordinary, but because it reminded us how little we truly understand about the space beyond our solar system. To understand why this matters, we need to go back to the beginning. In the 1970s, NASA launched 2 spacecraft, Voyager 1 and Voyager 2, taking advantage of a rare planetary alignment first calculated by Gary Flandreau. This alignment allowed the probes to use gravity from the outer planets like a series of slingshots. What would normally take decades could be done in years. Voyager 2 launched in 1977 and went on to achieve something no other spacecraft has done. It visited Jupiter, Saturn, Uranus, and Neptune. It revealed volcanic activity on Io, complex rings around Saturn, extreme weather on Neptune, and entirely new moons across the outer solar system. Then, after completing its planetary mission, it continued outward, toward the edge of the Sun's influence. Eventually, it crossed a boundary known as the heliopause. This is where the solar wind fades, and interstellar space begins. Scientists expected this transition to be gradual. Instead, it was turbulent. Voyager 2 detected sudden changes in plasma density, shifts in magnetic fields, and pressure variations that didn't fully match earlier models. Since then, the spacecraft has been exploring the interstellar medium, a region we've never directly studied before. And here's the key point: it's not empty. It's filled with charged particles, magnetic fields, and waves moving through space in complex ways. Some of these create what scientists describe as a plasma hum, low-frequency oscillations that can travel vast distances. These signals can appear structured, even rhythmic. But they are natural. In recent years, communication with Voyager 2 has become increasingly difficult. At one point, contact was temporarily lost due to antenna misalignment within NASA's Deep Space Network. When the connection was restored, engineers had to carefully interpret weak and sometimes corrupted data. And that's where confusion can begin. Because when signals travel over billions of miles, they don't arrive clean. They're affected by interference, noise, and the interstellar medium itself. Small irregularities in timing or frequency can look unusual, even meaningful, when taken out of context. But in most cases, they can be explained by plasma interactions, magnetic field turbulence, signal degradation, or aging spacecraft systems. It's also important to understand the condition of Voyager 2 itself. This spacecraft is over 45 years old. Its systems are being gradually shut down to conserve power. Its instruments were never designed to operate this long. So occasional anomalies in data are not just possible, they're expected. That doesn't make the mission any less remarkable. In fact, it makes it more extraordinary. Because even now, Voyager 2 is giving us our first direct measurements of interstellar space. Real data from beyond the Sun's influence. But here's where we need to stay grounded. There is no confirmed evidence that Voyager 2 has encountered anything artificial. No verified signal showing communication from an external source. No data indicating an object interacting with the spacecraft. What we are seeing is something equally important, a reminder that the universe is complex. That plasma can behave in ways we don't fully predict. That magnetic fields can shift, ripple, and interact across enormous distances. And that when you push exploration this far, you start entering territory where models are still incomplete. Voyager 2 hasn't discovered something, watching it. But it has revealed that interstellar space is far more active than we once believed. More structured. More dynamic. and still largely unexplored. And maybe that's the real takeaway. Not that we've made contact, but that we're finally beginning to observe the true nature of the space between stars. A region that, until now, existed only in theory. Even today, Voyager 2 continues to send data across more than 18 hours of travel time at the speed of light. A tiny signal, crossing billions of miles, carrying information from a place no human-made object has ever truly explored before. So the next time you hear about a strange transmission, remember this: sometimes the mystery isn't a message. Sometimes the mystery is